Okay, this video is on rational exponents. Rational means fractions, so we're talking about exponents that are fractions. Before we get started, let's take some time and get acquainted with our scientific calculator. If you don't have it, might as well go grab it. Okay, let's calculate these. So first type in the base and then the exponent key. Your exponent key might look like a box with a little box for an exponent. The first big box is for your base, and the second little box would be for exponent. Maybe it's a TI, and it has a X to the Y button. That could be your exponent button. Or it might look like the top of a triangle called a caret. Anyway, so depending on your calculators, you do it differently. So 3 to the power of 4, it should give you 81 on your calculator. Okay, let's type in a negative exponent. So 2 to the power negative 3. Make sure you use the negative sign on your calculator, not the minus sign on your calculator. So 2, and then your exponent button, and then type in negative 3. And depending on your calculator, it might show up as a decimal, 0.125, or it might give you a fraction automatically, 1/8. If it gives you a decimal, there's usually a way to change it from decimal to fraction. It usually has a D and then a arrow going in both directions and then F. On a graphing calculator, you might have to go to I think it's the math button, and then there's a way of changing it to fractions. And if you want a decimal and it gave you a fraction, you have a button on your calculator that says SD. And in between the S and D is the arrow in both directions. That'll change it to a decimal. Alright, so hopefully that worked out. Here's the next one. 27 to the 2/3. That should give you 9. Or 64 to the negative 2/3. That should give you 1/16. You might have to go to YouTube and type in your model number of your calculator, and there's always plenty of videos on how to use your calculator if you're having trouble. Okay, here's our rule. If m over n is a positive rational number, then b to the power m over n is equal to the nth root of b to the m, or you can move that m outside the parentheses, so it's the nth root of b all raised to the power m. Usually that second form is what we want. So the nth root of b in parentheses, and then the m on the outside. Okay, so try to remember that the denominator, that denominator n, is always going to be the index number. So what we're doing is we're giving an expression with a rational exponent, and we're going to change it to radical form, and hopefully we can simplify it. Okay, so here's some examples. 27 to the 2/3. So remember, the bottom number is going to be your index, and the top number is going to go outside of the parentheses. And the 27 is going to go inside the radical. That will be the radicand. Okay, now we can do the cube root of 27. What is the cube root of 27? Right, that would be 3. So that'll be 3. We're going to bring that down. Keep the exponent of 2 on the outside. So now we have to do 3 squared, which is 9. We're all done. I know you could probably do this on your calculator. We're going to have problems with variables. which you probably will not be able to type into your calculator. So you always want to learn the procedure, and then if you want to, go ahead and use that calculator to make things easier, but you might not even be able to use your calculator. Okay, pause the video and try to work out the next ones on your own. Okay, 25 to the 1/2. Again, the bottom number is your index. So I wrote it in there, but you don't have to write in the 2. It's always an assumed 2 if you do not write it. The top number, the 1, that goes outside the parentheses. So now we have the square root of 25, which is 5, raised to the first power, and that will be 5. 81 to the 3/4. Again, your bottom number is the index number. The top number is written outside the parentheses. Fourth root of 81, what times itself 4 times is 81? Or what number raised to the 4th power is 81? That would be 3. So 3 cubed is 27. Last one, 49 to the 3/2, 3/2. The 2 is your index number. The top number goes outside the parentheses. Square root of 49 is 7. And 7 to the 3rd power is 343. Okay, the same kind of problem, only that our radicand is going to have a variable or variables inside. So here our radicand in part A will be 8x to the 12th. The 3, the denominator, will be your index, and the 2 will be written outside of the parentheses. Cube root of 8, that would be 2. And then 3 goes into 12 4 times. So we get 2 to the 4th, all squared. Now we need to square the 2 and multiply the exponents. So 4x to the 8th. Part B, same thing. Our 2 is the index, and 1 will be written outside of the parentheses. The square root of 81 is 9. And then divide 10 and 4 by the index, which is 2. So 9x to the 5th, y squared, all to the first power. Anything to the first power will be the same thing. So there's your answer. Okay, last one. 4th root of 16x to the 8th, y to the 20th, all to the 3rd power. The 4 is our index. The 3 is written outside the parentheses. The 4th root of 16 is 2. And then divide our exponents by 4, so that will give you 2x squared, y to the 5th. Now that is raised to the 3rd power. So 2 to the 3rd power will be 8. And then multiply our exponents. 2 times 3 is 6, and 5 times 3 is 15. Okay, now we have a fraction with a fractional exponent. Same process. Our fraction 4/9 will be the radicand. 2 will be the index, and 3 is written outside the parentheses. Now you just have to think about the numerator and denominator separately. So what is the square root of 4? That would be 2. And what's the square root of 9? That would be 3. So we have 2/3, all of it to the 3rd power. Again, you have to think of them separately. The numerator to the 3rd power and the denominator to the 3rd power. So 2 to the 3rd power is 8, and 3 to the 3rd power is 27. So when you have an exponent outside the parentheses of a fraction, that exponent applies to both the numerator and the denominator. When you have an index of a square root, that index number applies to the root of the top number and the bottom number. Okay, let's try the next one. 27 over 125 to the 2/3. So again, write the cube root of the fraction raised to the second power. Now the cube root, that's going to apply to the numerator and the denominator. So the cube root of 27 is 3. And the cube root of 125, right, that's 5. So 3 over 5 raised to the second power. Now each numerator and denominator is raised to the second power. So 3 squared is 9. 5 squared is 25. Okay, one more. Same thing, our index is 4. And the number outside the parentheses is 3. Now we'll do each separately. The fourth root of 16 is 2. Because 2 to the fourth power is 16. And the fourth root of 81 is 3, because 3 to the fourth power is 81. And now we'll raise each to the third power, and that gives us 8 over 27. Okay, same idea. These just have variables in the problem, so it's still the same process. The first one, the index is 3. 2 is written outside the parentheses. So now we're going to do the cube root of 27x to the 9th. So the cube root of 27, what times itself 3 times is 27? That would be 3. And then 3 goes into 9 3 times. So you should have a 3x to the third on the top. On the bottom, cube root of 64 is 4. And then 15 divided by 3 is 5. So you should have 3x to the third over 4y to the fifth, all of it to the second power. Okay, now we're going to simplify this expression. The 2 outside applies to both numerator and denominator. So 3 squared is 9, and 4 squared is 16, and then you multiply all the exponents. 3 times 2 is 6, 5 times 2 is 10. Okay, our next one, a little bit different because we have a negative inside the right hand. Again, our index is 3, our exponent outside is 2. Now, can we have a negative inside the radicand if the index is 3? Yes. As long as the index is odd, we could have a negative inside. If the index is even, it's not possible. Okay, so we're okay here because our index was a 3. All right, cube root of 8 is 2, and then divide 3 into 3. Cube root of 125 is 5, and then 3 into 6 is 2. And because it's a negative, our answer will be a negative. Because negative times negative times negative will give you a negative. Okay, now we need to raise that to the second power. So 2 squared would be 4. 5 squared would be 25. Multiply our exponents. And that negative, well, when we have a negative squared, our answer will be positive. So we're going to lose the negative. So our final answer is 4a squared over 25b to the fourth. All right, this time we're going to have an index of 5 and a 2 on the outside. Let's see, the fifth root of x to the 25th. That'll just be x to the 5th. We divide 25 by 5. In the denominator, the fifth root of 32 would be 2, because 2 to the 5th is 32. And the exponent of the y will be 2. 10 divided by 5 equals 2. Now we're going to raise each to the second power, the numerator and the denominator. Numerator, multiply 5 times 2 is 10. On the bottom, 2 times 2 is 4, and then 2 raised to the second power is also 4. So x to the 10th over 4y to the 4th. Okay, previously we've covered negative exponents. So this is actually a review. We don't have a fractional exponent here, but we want to make sure that you remember this topic before we tackle the next problems. Remember that when you have a negative exponent, you move the base to the denominator, and then you change the exponent from a negative number to a positive number. All right, so here's 2 to the negative 3. Put it on the bottom, and it becomes 2 to the positive 3. And then 2 to the positive 3 is 8. So we get 1/8. Mm-hmm. 5 to the negative 2. Again, same process. Put a 1 on top, and then put 5 to the positive 2 on the bottom. Now 5 squared is 25, and you're all done. 1 over 25. The next two are a little bit different because our base is negative. Still the same process. 1 over negative 4 squared. And then negative 4 squared would be positive 16 because there's two of them. And then the last one, 1 over negative 5 to the third power. Now that gives us negative 5 times negative 5 times negative 5. That's going to be negative 125. So we have a negative. Usually you want to put that negative in the middle of the fraction, proper form. Okay, here we have not only a negative exponent, but a negative fractional exponent. Still the same procedure. We're going to move the base to the denominator and then change our exponent to a positive. Then we're going to write it in radical form and simplify. Okay, so first thing is move the 9 to the 1/2 to the denominator and then change your exponent to a positive. Now the 9 will be inside the radicand. The 2 will be our index number, the bottom number is our index, and the top number is outside the parentheses. Now the square root of 9 is 3, and we have 3 to the first power, but that's still 3. So this 9 to the negative 1/2 is equal to 1/3. 81 to the negative 3/4, same thing. Put it under a 1, change the 3/4 to a positive. Write the denominator in radical form. The bottom number is the index. The top number is outside the parentheses. Now we have 4th root of 81, which is 3, raised to the third power, 27. 1 over 27. Look here, next one. Again, the negative 64 is in parentheses, so keep it in parentheses. You're going to move to the bottom. the 1/3 will become a positive. So 1 over negative 64 to the 1/3. Put the negative 64 under the radical. The 3 is our index. 1 is outside the parentheses. Now again, because it is a cube root, we can have a negative in the radical. If it was a square root, it would be no real number. But the cube root of negative 64 is negative 4. And negative 4 to the first power is still negative 4, so we do not lose a negative. And then you want to put the negative in the middle of a fraction. Okay, these are going to be the same, just that we've added variables this time. So the first thing is, move the whole thing to the denominator, and the exponent changes to a positive. Now write the denominator in radical form. The 2 will be the index, the 3 will be outside the parentheses, and the 4x to the 6, y to the 12 will be the radicand. It will be inside the radical symbol. Now we need to do the square root of 4x to the 6, y to the 12. Square root of 4 is 2, and then divide 2 into 6 and 12. So that would give us 2x to the 3rd, y to the 6, all raised to the 3rd power. Now we're going to raise the 2 to the 3rd power. That gives us an 8. And then multiply the exponents. So it's 1 over x to the 9th, y to the 18th. Okay, our next one. It has an exponent of negative 5/3. We're going to move the expression to the denominator. Make the negative 5/3 a positive 5/3. Then write it in radical form. The 3 is our index. The 5 is outside the parentheses. Cube root of 8 is 2. Divide 3 into 9 and 3 into 15. So in the denominator, that gives us 2x to the 3rd, y to the 5th, all of it to the 5th power. And now we're going to raise 2 to the 5th power and then multiply the exponents. Okay, almost there. Now we have a fraction, not only with a fractional exponent, but a negative fractional exponent. We have this property. You may have seen it before, you may not have. Whenever you have a fraction to a negative exponent, it's equal to the reciprocal of that fraction raised to the positive exponent. So this may be a new property. What it's saying is, if you have a fraction with a negative exponent, you can flip the fraction and then change the exponent to a positive. That's kind of nice, right? It's really a shortcut. You could still do the same thing. You could put the 4/9 in the denominator to the positive 3/2, and then you would have a complex fraction, but we don't want to go there. So this is a shortcut. You flip the fraction and you change it to a positive exponent. And then we covered that earlier in this video. So the first one, we flipped the fraction, so it was 4/9. Now you make it 9/4, and then the exponent changes to a positive. Now we're going to write that in radical form. By the way, I'm writing this one horizontally. The last examples, I was writing it vertically. It's just a preference. If you want to write it horizontally, you can. Okay, so 2 is our index. The 3 is written outside the parentheses. Now we have to do the square root of the numerator over the square root of the denominator. So that would be 3 over 2. And then raise each to the third power. 27 over 8. Okay, next one. Again, we're going to flip the fraction. Even though it's negative, when you flip it, it'll still be negative. So 8 over 27. Now the negative 8 over 27, that's going to be our radicand. The bottom number is our index, and the top number goes outside the parentheses. This is a cube root, so we can have a negative inside. Cube root of 8 is negative 2. I should say the cube root of 8 is 2. And the cube root of 27 is 3. Since it's a negative inside, our answer will be negative. So negative 2/3 to the 5th power. Now we're going to raise each to the 5th power. When you raise a negative to the 5th power, the answer will still be a negative. So negative 32 over 243. Almost done. These are our last examples. Now it's a fractional exponent, a negative fractional exponent of a fraction. This time our fraction has variables. Okay, still the same rule. We flip the inside and make it a positive exponent outside. Now we're going to write it in radical form. 2 is our index. 3 is the exponent outside the parentheses. Now perform the square root of the numerator over the square root of the denominator. Square root of 25 is 5. And 2 goes into 2 one time, so 5x on top. Square root of 16 is 4, and then 2 goes into 10 5 times. Now raise each to the third power. 5 to the third power is 125. 4 to the third power is 64. Multiply the exponents. The exponent on the x is just a 1, so 1 times 3 is 3. On the bottom, 5 times 3 is 15. Okay, last one. Flip the inside. Change the exponent to a positive. Now write it in radical form. 4 is the index. 1 is outside the parentheses. 4th root of 81 is 3. 4th root of 16 is 2. And then 4 goes into 25 times. And being raised to the first power is itself. So we've done it. We're all done. See you here for the next one.